Continuing our examples of Newton's third law. Now the apple is held by a physicist, right? Here's that apple. Both are at rest. Draw an interaction diagram for the apple, the person, meaning the physicist, and the earth. So the apple and the earth are continuing to interact through gravity, as before, but the apple is no longer touching the earth. So there's no more normal force between the apple and the earth. Instead, what is the apple touching? The person. So we're going to have a normal force here. Okay? And now the earth and the person are also going to interact through a force of gravity. And this person is touching the earth, so there's also going to be a normal force here. And then lastly, some of you might say, is there going to be gravity between the apple and the person? Because if you know about gravity, it's an interaction between any two objects with mass. And so I would say yes, there is a force of gravity between the apple and the person, but it's so small that we can ignore it. But I'm going to put it as a dashed line, okay? So it is present, but we are going to ignore it in our free body diagram, okay? So we're starting to get a lot of interactions here, and so I'm going to just show you a little method for staying organized. So one thing that's helpful is to start with a figure like the apple and count the number of lines coming out of it. Again, we're ignoring gravity. So apple has two forces coming out of it, right? We've got the normal force here, this line, and this line coming out of it, okay? The person has three interaction lines coming out of it, and the earth has three interaction lines coming out of it. So that's the number of forces that we need to show on each object. Let's start with the apple, right? So the apple has coming out of it, right, this normal force, and it's got this gravity force coming out of the apple. So let's add those. We're going to have gravity coming down. And follow the line, right? So we've got gravity, and what's the source of that gravity? It's the earth. And we've got a normal force. What's the source of that normal force? The person, okay? So use the diagram to help you identify the sources. So gravity is coming from the earth, and there's an upward normal force on the apple from the person, okay? We're done with the apple. We've got two forces. Let's go to the person. The person is supposed to have three forces acting on it, right? So let's follow the lines. We've got a normal force from the apple, we've got a normal force from the earth, and we've got a gravity force from the earth. So let's add those on our picture. The person is being pulled down by the force of gravity from the earth. The person is being supported by a normal force from the earth. And then the person is also experiencing a normal force from the apple, okay? So imagine you're the person, you're holding an apple in your hand, you would feel the apple pushing down on your hand. So I'm going to draw that downward normal force from the apple. And by the way, many textbooks would say, don't draw it there, draw it in line with the other force, which I'm having a hard time doing, if I can isolate that. They'd say, no, pull it down here, right, to be in the same line to show that the force is acting along the center of mass of that object. That's great too, okay? And then we're ready for the earth. The earth has three forces on it, two forces of gravity and one normal force. So according to the picture, the earth is being pulled by the force of gravity from the person. We see that one here. It's being pulled by the force of gravity from the apple. So we're going to have actually two forces of gravity on the earth, right? One of them is from the apple. One of them is from the person. And then it's got this normal force here from the person. So the earth feels the person standing on top of it. The person is pushing down on the earth. So we would show this normal force from the person. How does this demonstrate Newton's third law? Again, every interaction has a pair of forces. I'm going to say every action involves a pair of forces. Every interaction involves a pair of equal and opposite forces. It's getting harder to see the pairs, but let's take a look here, right? If I change colors. So this force of gravity on the apple by the earth, where is its pair? It would be the force of gravity on the earth by the apple. So it would be this one. Those are pairs, right? They're equal and opposite. Let's identify another pair. What if we were looking at this one? The normal force on the person from the earth. Where's that pair? Normal force on the person from the earth. It would be the normal force on the earth from the person, right here. So those are equal and opposite pairs. All right, we've got one more.